Hello again, this is Jack Sheffield, Jack the exam guy. We are going to be talking about pile capacity today, and I need to give you some fair warning. This is complicated, okay? If math is your weak area, you may not even want to jump into this, but you can give it a try. If you've got some pretty good math skills, then you'll probably be able to get through it pretty good. But I just wanted to let you know ahead of time, give you a little bit of fair warning. It is not for the faint of heart. However, the first part of it's not so bad. Okay, so bear with me for just a minute here. Okay, so we're talking about pile capacity. Okay, how much weight will this pile support? The first thing that you have to know is that pile capacity, piles support load in two ways. In shear, okay, this is the force, this horizontal force of the soil against the piling. Okay, and that happens all the way around the piling, obviously. And then you have bearing, okay, on the tip of the pile, you have bearing. If you know that the total capacity of the pile is your bearing capacity and plus your shear capacity equals your total capacity, then that gets you where you need to be to answer the most basic questions about pile capacity. And you don't have to have a lot of good math skills to know that. Okay, they'll give you a scenario where they give you the total pile capacity, and then they'll give you the bearing capacity, and then all you have to do is subtract the bearing from the total, and you get the shear. It could be that simple. Okay, but if you have to calculate the actual capacity, then that's where it gets a little more complicated. Okay, so here we go. We're going to follow this sample that they have in the book to explain what's going on here. So I'm on page 117 of the Principles and Practices of Commercial Construction. What they're telling us is this is an example question, left-hand column, second paragraph. Okay, here's our example. A 35-foot wooden pile having an average diameter of 12 inches and a tip diameter of 8 inches is driven into soil that has an allowable bearing capacity of 4 tons per square foot. Okay, so our soil has a capacity of 4 tons per square foot and a shear strength of 700 pounds per square foot. All right, determine the safe carrying load of the pile, assuming the top 6 feet do not resist any load due to unstable soil conditions. Okay, you got all that? All right. Well, if you didn't, it's on page 117 there, left-hand column, second paragraph. So here we go. We have this 12-inch in diameter piling with an 8-inch tip. Okay. And it's 35 feet long, but we only are going to account for 29 feet of the piling because the question told us that 6 feet of it was unstable soil, and we could not count on that doing anything for us. Okay, so here we go. So the question told us our soil bearing capacity was 4 tons per square foot, also known as 8,000 pounds. So you're going to need to know that. You're going to need to convert the tons to pounds at some point because we have to be working all in the same units for anything to make sense. Okay, we've got to be working all in feet and all in pounds, and then we're going to come up with a number that actually means something. If we start talking about inches and then tons and mixing all that up, then our answer is meaningless. So we're going to work in pounds and feet. Square feet, is fine as long as it's feet. So we have soil bearing capacity of 4 tons or 8,000 pounds per square foot. We have a soil shear capacity of 700 pounds per square foot. All right, so this is our soil. All right, so here we go. Remember, our bearing and our shear equal our total capacity. Bearing capacity plus shear capacity equals total capacity. Let's do our bearing first. Well, in order to know what our bearing capacity is, we have to know how many square feet that tip is. Okay, and then once we know how many square feet that is, we multiply that times the 8,000 pounds per square foot, and we'll get our pounds of bearing capacity. Okay, so how do we figure out the square footage of the tip? Remember pi r squared? Sure you do. Okay. So pi, 3.14 times our radius. Now our radius, remember, is 4 inches because it's half of the diameter of the tip. And then we have to convert it to feet, so it's 0.33. So it's pi times 0.33 times 0.33, that's pi r squared, times our pounds per square foot. Okay, and that's going to give us our bearing capacity. All right, so our bearing capacity is 2,736 pounds per square foot. Now, if you're comparing this to the calculation in the book, you're going to see it's slightly different. Well, they use some slightly different type of calculating methods. And I got to tell you, you have to be an engineer to be able to figure out what they're doing there. So don't even try it. It's just go with the pi r squared. That's tough enough. We're getting real close here with what we got going on. Okay, so this is our bearing capacity. All right, so now we got to go figure out our shear capacity. Now this gets a little trickier because we have to figure out how many square feet this piling are going to be exposed to that soil. All right, the good soil. All right, so if we need to get the circumference of that pile, which is pi times our diameter. Okay, we know it's 12 inches. Remember, we have to be dealing in feet, so that's 1 foot, times our length. Remember, that's 29 feet of length of pile that's doing us any good. And then it's times our soil capacity of 700 pounds per square foot. Hey, then it's just crunching numbers. 3.14 times 1 times our length, 29 times 700, our soil capacity, and we get 63,742 pounds, okay, of shear capacity. So all we have to do now is just add our bearing capacity and our shear capacity, and we get 2376 for our bearing, 63,742 for our shear, and we get 66,118. If you followed that, you're doing pretty good. Okay, and you could have to do this on the exam. More than likely, it's going to be the other more simpler one that I was talking about there, where all you really have to do is know that your bearing capacity plus your shear capacity equals your total capacity, and then you're just going to have to crunch the numbers that they give you. Be careful about that, though. They like to talk in some pretty tricky terms, so make sure that you read those questions. Like all questions that you're going to take on this exam, read them carefully. Take some time, read them carefully. Okay, well, that was a lot, and I appreciate you listening. This is Jack the Exam Guy, and I appreciate your business.